Today we're going to talk about the surface area of a pyramid. So we have some vocabulary. Pyramid is a vocabulary term, is a polyhedron in which one face, called the base, can be any polygon. It can be, well, any polygon. And the rest of the faces, called the lateral faces, are all triangles that meet at a point called the vertex.
Should we write all that down?
You should write down the words, and they're vocabulary words. They will be on your quiz on Friday. What? Okay, so pyramids are named by what shape the base is. So the first one here, the one on top, the base is a hexagon, so this is called a hexagonal pyramid. And then here the base is a square, so of course we call that one a square pyramid. Math is nothing if not logical. Okay. If you could picture that a pyramid is transparent and you can see through it, you would see that there's a line that's drawn straight down from the base, from the vertex, that is perpendicular to the base. That is called the altitude. And as with our other figures, the length of the altitude is called the height. Now compare that to a line that goes from one of the lateral faces to the vertex. That is also perpendicular to the bottom of the lateral face, and it goes up to the vertex. That's called the slant height. So you have to be able to differentiate between the altitude and the slant height. The altitude goes through the center of the pyramid and is perpendicular to the base. The slant height goes up the sides of the pyramid and is perpendicular to the edge. Not necessarily perpendicular to the base. Now on a regular pyramid, you can see here it does say that the slant height, the slant height is the length of the altitude of a lateral face.
Speak Spanish.
I'm speaking man. And just note that for purposes of you solving surface area problems, for all the problems in the book, you can assume that it's a regular pyramid unless you are specifically told otherwise. It is highly unlikely that you will be given a problem where the pyramid is not a regular pyramid because it changes how you do the problem. This is chapter 11.
What was the book after that?
8 and 10. All the stuff we've missed. And the words are up on the board. I think I'll double check to see if there's anything missing. Okay, another minute, please. And then we're going to get going.
So we're not going to really count for hexagons.
No, you might, but you're not. It's still a regular pyramid. So the hexagon is a regular polygon. Or it could be a regular polygon.
Oh, so it's just saying if like a pyramid has like.
Well, I wouldn't even worry about it. Okay, so we have two more formulas, I should say. Okay, that is the lateral area of a pyramid and the surface area of a pyramid. The lateral area of a pyramid is half the product of the perimeter of the base times the length of the slant height.
Is that the slant height symbol?
No, that's an L. I don't want to just draw a straight line L because it'll look like a 1. So the lateral area is 1/2 P times L, where P stands for the perimeter of the base and L stands for the slant height. The surface area, as for every other shape, is the lateral area plus the area of the base. What differentiates a pyramid from a prism, obviously, is that a pyramid only has one base, whereas a cylinder and other types of prisms have two bases. So you're still going to have to find the area of the base, and the formula you use will be determined, of course, by what shape the base is. If it's a square, it's one type of formula. If it's a hexagon, it's another type of formula. Okay, so as a matter of fact, the first question we start with is a hexagonal pyramid.
So these are pyramids?
All right, so I'm not going to draw the pyramid, but I am going to put the length of the different parts to it. Well, let me see if I can. Okay, in order to find the lateral area, we need to find the perimeter of that base. So what do we know about the base? Andy, what do we know about the base of my pyramid? It is not shaped like a stop sign. It is a hexagon, not an octagon.
I don't know. I was drawing it.
All sides are equal, that is true. So what do you know about one side of it?
One side.
Huh? 6 inches. So then what's the perimeter? One side is 6. How many sides are there? So the perimeter is, so the perimeter is 36. Okay, now we have enough information to find the lateral area. So the lateral area is 1/2. We know the perimeter is 36. L stands for the slant height. How much is the slant height in this figure? 9. So we have,
How do we know this?
how do we know it?
Never mind.
So we have 1/2 times 36 times 9. get 162. Okay, now we're going to come over here. The surface area is the lateral area plus the base. Well, we know what the lateral area is. We just have to figure out the area of the hexagon. We know that the formula is 1/2 the apothem times the perimeter. So to get the area is 1/2 the apothem times the perimeter. We know the perimeter is 36. What's the apothem?
Radius.
The apothem is the line that goes from the center of the polygon to the edge, which is 3 times the square root of 3. Now we just multiply all those numbers together. It gives us 18, gives us 54 times the square root of 3. The problem wants us to give it an answer rounded to the nearest whole number. So now I just have to take my 162 plus 54 times the square root of 3. Take all that and plug it into my calculator. So I'm going to do 54 times, here's my square root button. I don't like the calculator. Okay. So I have 54 times the square root of 3, gives me 93.5. Add to that 162, gives me 255.5. The question says round to the nearest whole number. So I get 256 square inches. Okay, does anybody have any questions? All right, unfortunately we did not get to finish the lesson today. So we will finish tomorrow.
Is there homework the same? Is it like 7 through 8? All?
No. Your homework is no longer number 7 through 12.